So yeah, welcome everybody. My name is Steffen Christgau. I'm a HPC consultant from Zuse-Institut in Berlin, Germany. And for those of you who don't know Zuse-Institut, so we are one of 9 essentially level 2 or tier 2 HPC service providers in Germany for academic use only. So we are a member of our national HPC alliance called NHR. We have quite some history and we are also quite successful in the IO 500 list thanks to DAOS. So at ISC24 we were actually ranked 3rd in the 10 node production systems. Shortly we were outperformed by a short margin, so we are now on rank 4 essentially. But we still have DAOS not brought to our user base essentially, but that's something we are working on, and that's what I want to talk about today. And the challenges that we face and what experiences we got from using DAOS. What makes our institute a little bit special, or our situation at ZIB special, is that funding is a little bit different from what you may be used to. So we are currently forced to invest on an annual basis. So we are not able to purchase a new system, like a big system, like every 5 years or so. But at the moment we are forced to increasingly extend our existing system. So we still have an old Cascade, old in quotes, Cascade Lake cluster as a primary production system with some extensions attached to it. However, there is a network gap, so to say, or network challenging as well. So in our old base or old production system, which is still the largest part of our system, we use Omnipath 100 as network. And for all the extensions that we have, which are primarily GPU-focused extensions, we use InfiniBand. So that makes our system a little bit complex. However, attached to the DAOS, to the CLX or Cascade Lake partition, so the Omnipath partition, we have the DAOS installation attached to it. This is for historical reasons. So DAOS came before all the extensions, but nevertheless, this is kind of a challenge. Over the time, we also purchased new storage. So until this year, in this year, we switched from an IBM DDN Lustre installation to IBM GPFS installation for our main storage system, which allowed us a comparison of like 2 production file systems like Lustre and GPFS in our production system, so to say. And then we could compare that to DAOS, right? So that's our system basically put in a picture. So we have the primary or still largest part of the system, which is the Cascade Lake partition with Omnipath 100, and there is DAOS attached to that. And in addition, we have all those extensions of different size, which are attached to InfiniBand networking. And this is also where the current storage, the current main storage, so the GPFS file system is attached to. The old Lustre file system was attached to the Omnipath network natively. So for making DAOS available to users, one of our admins took care of that. We only make it available to users on the old Lisa system, which is the Cascade Lake partition of the system. And by default, we simply start the agent, which is basic requirement to use DAOS from a compute node. For onboarding new users or interested users, our intention is to make it very easy to users. So we automatically mount a Scratch container in the job prologue and unmount it in the epilogue, so that users do not have to bother with container handling. And actually, this is also a consequence of our security policy, because no binary should exist in the system which has SUID bit set. So this makes it difficult to have a fuse amount, which is used under the hood of Diffuse, available to users. So that's why we actually haven't any binary available that allows mounting in the file system. However, in the prologue and epilogue, we shortly enable the binary, do the stuff with this Scratch temporary container, and unmount the container and switch SetUID bit, so to say, in the epilogue as well. So that's kind of a challenge for us right now, because our security policy is like that. But actually our system is, from the administrative part of view, changing like responsibilities, and so we may rethink about our security policy here, also to enable DAOS usage. But that's currently our challenge that we have. What we also do in our system is, based on a hint of Michael Hennecke, he is in the audience, we use licenses, a feature in Slurm, where you can essentially like limit usage of something, and something here is essentially DAOS. So this is actually like a feature to get the DAOS system exclusively for you for benchmarking, which is what I used during these experiments here. Actually, it has not any consequence of using DAOS, like it has no consequence on the usage of servers, pools, or targets, or whatsoever. But you can just limit like the number of users with this feature in a more or less hacky way to use the DAOS installation. From a consultant point of view, like my point of view, we did an application study as well. So one of our prominent examples or codes that is running on our system is Palm. Scientific application, don't ask me about any details. It's a highly scalable code, so it scales to the full system if users wanted to do that. But what is interesting from the I/O point of view is that it has a checkpoint and restart mechanism that can use like multiple backends. So it can use like pretty straightforward Fortran I/O, which is like dumping memory dumping a variable directly into a file. And then there are two like backends which use MPI I/O. One of them is using MPI I/O directly for every process. So every process writes to a shared file, which is different to the Fortran thing, whereas you have a process per file scenario. And there's an additional backend which is using MPI on top of or together with shared memory. So first, data is aggregated within a single node and then written to a shared file from a single process per node, so to say. So you first aggregate locally and then write to the shared file. And that makes it interesting because you now have an application that supports like multiple ways to do the checkpointing. It's not a time-critical thing, but it was interesting to just have a look on how you make it use DAOS and how the performance is actually, and how it performs on the different file systems that we had over the course of those experiments that we did. So these are actually the questions that we ask ourselves, like, does it actually work? What is required to make changes to let Palm use DAOS? And what's the impact on performance with respect to the file system and to the different I/O backends or checkpointing restarting backends? So in the experiments that I'm going to show right now is what we are using here is like roughly 9,000 MPI processes, like distributed on 96 nodes with 96 processes per node. The checkpoint that we create is not gigantic. It's like 5 terabytes in size. And what we did here in the experiments was running all writing and or reading from the checkpoint 923 times, and we report the median here. So for using Palm's checkpointing mechanism with DAOS, we essentially relied on Diffuse for the Fortran I/O part. So we mounted the container and used the interception library, which was already mentioned in the talk before, and disabled caching for getting like the native performance of DAOS, not like what we get from writing into caches. And for the MPI I/O parts, we just use the ROM I/O layer of, in that case, Intel MPI, which has native support for DAOS. And we did some things in runtime environment, like exporting some variables just to get it running, but that was like very easy to do. The only thing that we needed to adjust in the application was to accept like user-provided file paths for the checkpoints. Originally, it had like a fixed path included, which is the working directory of the application, but it makes it difficult to use like the native ROM I/O layer support in MPI if you want to write to a current directory which is actually not existing in the file system. So what we asked ourselves was, what is the impact of the different object classes, like essentially replication and striping, so to say, across the DAOS targets? And there was actually no much of a surprise here. So if you increase or decrease the number of targets that you write to or shards that you write to, you decrease the performance, right? So here you see the different object classes that were in use, like with going from left to right, you decrease the number of targets that you write to, and with that you also decrease the performance, both in reading and writing the checkpoint. So if we want to go for performance here, we should, what we would do as consultants is that we would recommend to use the SX whatever class here. If you want replication like data protection enabled, you of course lose a little bit of performance as well. So that's something you should keep in mind if you want to recommend certain object classes to your users. So that's our experience here. Yeah.
Write performance is higher than the read performance.
Sorry again?
Do you know why the write performance is higher than read for SX?
No.
But it should be because it's. Oh.
I hope not. So I took care of evaluating the data. So yeah, that's interesting. But yeah, I haven't an answer here. So continuing that, we asked what is the performance here for the different I/O methods that Palm is using. Questions after the talk, or?
We can hold,
Yeah, sure. Go ahead.
Oh, maybe is it because it's sparse? The read is, you're saying why is that? Because that big giant mesh looks like a CFD mesh.
Yeah, so yeah, that's a good point. So for MPI/I/O, it's like the compute domain is actually a three-dimensional domain. And for MPI/I/O, the application developers use MPI data types to define like the how the grid looks like. And that is then written to, or like passed to MPI/I/O as a data type, right? And so maybe reading is more expensive from perspective of MPI, I don't know. That's something we can look into. But at the moment, I don't have an explanation why it is like this. So regarding performance of the different checkpointing restart methods in Palm, the different backends, you see that Fortran behaves very well when it comes to write. It does not behave very well when it comes to read, because then the application crashes. But that's an application problem. I don't know why they haven't looked into this, so the application developers, because making a checkpoint when you can't read it doesn't make any sense, but it is how it is for the moment. I also observed it for regular POSIX file systems, but yeah. Performance is like much better for Fortran, because there you don't have this MPI overhead from my point of view, because it's just dumping data directly from memory into the storage system, not going on all these data types, having small chunks written over and over again. So yeah, that's why Fortran behaves quite well here. And MPI/I/O plus shared memory is a little bit better, because you aggregate a little bit beforehand and then write to the file system, which is not done for MPI/I/O solely. So that's why performance is here a little bit better. And maybe I just noticed that read and write, so read is worse here. Yeah, okay, so that's consistent. I hope I did everything right in my evaluation, but I'm pretty confident. So that's for the different application-specific ways to do I/O here, but again, this is application-specific. So what we encountered as challenges for using DAOS in our installation is that, as I said, diffuse violates our security policy. That's something we, on our side, may look into. What is even more biting us is like conflicting the fabric settings. So as I said, we have an OmniPath network where the DAOS installation is installed to. And for that, actually, you would use like PSM2, or if you are Brave user, then OPX network libfabric provider. However, there's no support officially, as far as we understand, from both PSM2. There's definitely no support for OPX. Maybe there will be support for DAOS, but at the moment there is not officially, as far as we know. So you can't use the native network providers for OmniPath in our case for like the DAOS access. So that's why we have to switch to the TCP provider here. But this also affects like application communication performance, which is like a bad thing, right? So the Palm application actually makes quite heavy use of the network. For the experiments, I disabled everything, like doing communication and just did the checkpointing. But in the end, it would hurt like application performance if we would use DAOS for this particular system that we have, right? So there is a conflict. Our hope is that there will be some kind of support in OPX network provider or the fabric provider, so that would improve even the performance, because right now all the data that you see here is gathered over TCP for accessing DAOS. And we hope that situation, as I said, improves here. For the application itself, we hardly had to do any changes besides this small adjustment to accept like external file paths that are not hard coded into the code. And what we want to go for is like using HDF5 for checkpointing and restarting. There's actually a work in progress implementation using netcdf for doing the checkpoints and not MPIO. But this is future work, so there's nothing that I can share for you at the moment. Looking at the different other file systems that we had in production in our system, so we had at the beginning of 2025, we still had a 10 petabyte DDN Lustre installation available, which was quite full, to be honest, but performance was still okay. Since as I said, 2025, we also have a GPFS installation available to our system. And we took the opportunity to compare like both production file systems to DAOS. In this particular case, using MPIO plus shared memory, because you get the restart functionality here. So in both cases, like for reading and writing, for Fortran IO, and MPIO, you get very good performance on DAOS, even though we are using TCP here. Lustre is also not so bad compared to GPFS, but one remark to GPFS on MPI. This is using OpenMPI, which is different to all the other experiments where I used Intel MPI. So I'm not sure if this 11.5 gigabytes per second here is due to using OpenMPI. No offense to OpenMPI, but maybe support is not so good here. However, data looks quite good for DAOS, so we would be very interesting to get it in production, and that's actually what we are looking for to enable DAOS to our users in the next few weeks or months. Let's see how it progresses, so we are continuing on working on that. So before opening the session here for other questions, thanks to Michael Hennecke for his support in getting parts of it running and also some hints that he gave to us. Thank you very much.
You said diffuse violates security?
Not diffuse. It's like when you use diffuse to mount a container, it uses mount under the hood, if I remember correctly, and that's actually not forbidden and not allowed in our system because there should be no binary at all that has S. Yeah.
Including suited?
Sorry?
Including suited?
Yes. So actually, no binary exists in our compute images. Yeah, that's a security measure that we took, I think, like 10 years ago already, and that's established policy. But right now, there, as I said, like the bodies that are looking over our systems do change. And we hope that we can convince like security board a little bit to get the system more usable.
And if your users are only writing and never reading data back, we can give you some optimization for writing.
True.
Your DAOS numbers, are they with the 4 kilobyte MTU or 2 kilobyte?
That's a good question. So actually, so the question is what MTU we are using here. So actually, for getting this system here to run, there's this little gray circle here, which are gateway nodes. So there are gateways between like our Omnipath network and the InfiniBand network, because otherwise the Omnipath nodes could not access our current storage. So, and if you want to combine like GPFS with gateway nodes between Omnipath and InfiniBand, you have to adjust for whatever reason. Please ask, as far as I know, IBM engineers. You have to adjust the MTUs between the networks. And that actually lowers networking performance on the OmniPath side. And we use the lowered, for the experiments, we use the lowered MTU here. I'm not sure about the number, that one I would have to look up, but I think it's 4 or 8K, I don't know, remember. It's definitely not the 12K or whatever it is on InfiniBand. Yeah.
So it would be much better if you would.
Yeah, it would be even more better. Like, so our hope is that we could increase like the very last graph way more to the right here.